Intermediate Algebra for Statistics, Finding Linear Equations. Lesson objectives: determine the equation of a line given a point and slope. Determine the equation of a line given 2 points. Lesson objective: finding an equation of a line by using the slope, a point, and the slope-intercept form. If you recall, the slope-intercept form is y equals mx plus b. To find the equation of a line using the slope, a point, and the slope-intercept form, number 1, substitute the given value of the slope, m, into the equation y equals mx plus b. Number 2, substitute the coordinates of the given point into the equation from step 1 and solve for b. Number 3, substitute the value of b from step 2 into your equation from step 1. And lastly, number 4, check the graph of your equation and make sure it contains the given point. Let's do an example. Example 1. Find the equation of a line that has slope m equals 4 and contains the point 2, negative 1. Solution: since the slope is 4, the equation has the form y equals mx plus b, but we know that m is 4, so we have y equals 4x plus b. So our next step is to find the value of b. To find b, we substitute the coordinates of the point 2, negative 1 into the equation y equals 4x plus b. So the given point 2 is the x coordinate and negative 1 is the y coordinate. So where we see a y here, we substitute negative 1, and the x coordinate we substitute a 2. And now we solve for b. So now we multiply. 4 times 2 is 8. Solving for b, we need to get rid of the 8, so we subtract 8 to both sides, and we get negative 9. So b is equal to negative 9. So our final answer is the equation is y equals 4x minus 9. To verify this, we use our graphing calculator. We hit the y equals button and we type in 4x minus 9. We hit graph, and here's our graph. And if we hit second graph, which is table, we want to make sure our point is listed. So when x is 2, y is 1, and that is correct. So we have verified the answer. Example 2. Find the equation of the line that has slope m equals negative 2/5 and contains the point negative 10, 3. Solution: since the slope is negative 2/5, the equation has the form y equals negative 2/5 x plus b. Next we find b. We substitute the coordinates of the point negative 10, 3 into the equation y equals negative 2/5 x plus b. Again, this is our x, this is our y coordinate. So substituting 3 for y and negative 10 for x, we have this equation. Next we have to multiply. Well, first of all, this is going to be a positive number. This is negative times negative is positive. And 2 times 10 is 20, divided by 5 is 4. So we have 3 equals 4 plus m. Subtract 4 to both sides. We see that m is equal to a negative 1. So the equation is y equals negative 2/5 x minus 1. To verify this using the calculator, we hit the y equals button and we type the equation in, hit graph, so we have our graph, and if we hit second graph, which is table, when x is 10, y is 3. So we have verified the answer. Lesson objective: Finding the equation of a line using 2 points and the slope-intercept form. To find the equation of a line that passes through 2 given points whose x-coordinates are different. Number 1, we use the formula for slope. M equals y2 minus y1 over x2 minus x1, or we use the graph to determine the rise and run. This will tell us the slope of the line containing the 2 points. Next, number 2, we substitute the m value that we found from step 1 into the equation y equals mx plus b. Number 3, we substitute the coordinates of one of the given points into the equation from step 2 and solve for b. It doesn't matter which point you pick. Number 4, we substitute the b value that we found in step 3 into the equation from step 2. And number 5, we check the graph to make sure it contains both points. Let's do an example. Example 3. Find the equation of the line that passes through the points 6, negative 2 and negative 3, 7. Solution. First we have to find the slope of the line. So that's the difference of the y's divided by the difference of the x's. I'm going to let y sub 2 be 7, y sub 1 be negative 2. Therefore, x sub 2 is negative 3 and x sub 1 is 6. Substituting these values into the slope formula, we have 7 minus negative 2 over negative 3 minus 6. 7 minus negative 2 is a positive 9. Negative 3 minus 6 is a negative 9. So we have a positive divided by a negative, which is a negative number, and 9 divided by 9 is 1. So the slope is a negative 1. Now we need to find b. So we substitute the coordinates of one of the points, either negative 3, 7 or 6, negative 2, into y equals negative 1 times x plus b. So if I use negative 3, 7, we have 7 equals negative 1 times negative 3 plus b, which gives us 7 equals 3 plus b. Subtracting 3 to both sides, we see that b is 4. Using the point 6, negative 2, the equation will become negative 2 equals a negative 1 times 6 plus b. Negative 1 times 6 is negative 6, so we have negative 2 equals negative 6 plus b. Adding 6 to both sides, we see that b is 4. So it doesn't matter which point you pick, you're still going to get the same value of b. The equation is y equals negative 1 times x, or we can just say negative x plus 4. Verify this using the graphing calculator. We hit the y equals button, type in negative x plus 4, hit graph, and then if we hit second graph, which is table, scroll through the values, look at negative 3, we see that y is 7, and when x is 6, y is negative 2. So we have verified the equation. Example 4. Find the equation of the line that passes through the points 8, 1 and negative 12, negative 9. Solution. We first find the slope of the line. So using the slope formula, again I'm going to let negative 9 be my y2. This is my x sub 2. This is my y1. This is my x1. Substituting those values in the slope formula, we have negative 9 minus 1 over negative 12 minus 8. This produces negative 10 over a negative 20. Negative divided by negative is a positive, and 10 over 20 reduces to 1/2. So the slope is 1/2. To find b, we substitute the coordinates of one of the points. It doesn't matter which. If I use 8, 1, we have y equals 1/2 x plus b. Substituting 1 for y and 8 for x, we have 1 equals 1/2 times 8 plus b. Multiplying first, we have 1 equals 4 plus b. Solving for b, we subtract 4 to both sides, and we see that b is equal to a -3. Using the point -12, -9, we have -9 equals 1/2 times -12 plus b. 1/2 times -12 is -6. Then we add 6 to both sides, and we see that b is equal to a -3. So it doesn't matter which point you pick. So the equation is y equals 1/2 times x minus 3. To verify the equation, we type the equation into our y equals. If we'd like to look at the graph, we hit graph. To verify the points, we hit second graph, which is table, and we see that when x is 8, y is 1. That agrees with our point. And if we go to -12 for the x, y is -9, and that agrees with our point. Example 5. Find the equation of a line that contains the points 3, 4 and -1, 4. Solution. We use the slope formula, which gives us 4 minus 4 over -1 minus 3, which gives us 0 divided by -4, which is 0. So the slope is 0. To find b, we pick one of the points. I'm using -1, 4. We substitute those values in. -1 times 0 is 0. So we have b is equal to 4. So the equation becomes y equals 4, because m is 0, and 0 times x is 0. So anytime that we have a horizontal line, the slope will be 0, and the equation will have the form y equals b, where b is the y-intercept. Example 6. Find the equation of a line that contains the points 5, 1 and 5, 3. Solution. Since the x-coordinates of the given points are equal, they both are 5, the line that contains the points is vertical. The equation of the line is x equals 5. So this is what the graph looks like. And if we tried to determine the slope, what we would have is a number divided by 0, which is undefined. That means it doesn't exist. So the equation of the vertical line is the only straight line that cannot be written in the form y equals mx plus b, because the slope is undefined. Thanks for watching.